Very welcome, everybody. How are you doing? How is everyone? Good. So we are going to continue with the discussion about the batteries. We have a little bit more practical lessons today because I'm going to teach you how to calculate the proper size of the battery voltage and battery current for the application, how to create the connection, and of course, how you are going to build your own battery pack, probably for your capstone project, or if you are going to be working in any automotive industry, definitely in there. This knowledge is fundamental, still basic. They are not super advanced. As I said earlier, we are going to have another advanced course in batteries in upcoming semester, which in there I'm going to teach you not only how to do it experimentally, definitely how to do it in MATLAB using simulation. Even before exposing yourself to the experimental setup, first validate your understanding, your design, your measurement, everything through MATLAB and Simulink, and then I'll get you to experimentally practice it using real battery cycler, using real battery cells, and I even get you to create your own battery pack. Also, we are not going to create high voltage battery pack. Still, the method of creating a battery pack means simply combining cells or battery cells which are included inside the module, either in series connection, which I'm gonna discuss it right now, or parallel connection, or matrix, right? Means a combination of series and parallel while you are connecting your battery modules together. In case of creating any high voltage battery, always you have to look at the capacity that you are looking for. Nowadays, most of the automotive industries, either RV industry or let's say regular vehicles such as like EV or maybe for any different application, even for motorcycle or so, when they are going to create the batteries, there are lots of characteristics that they need to consider. Definitely, as I discussed in the previous lessons, or I would say sessions about the batteries, because this is going to be the first session which I'm going to talk about the batteries. Definitely, the battery chemical has a really important impact on creating the pack. Why is that? Because of the chemical reaction, because how those materials are durable in terms of safety concern, in terms of like fast charge, fast discharge, and all of these things. Therefore, they are going to consider first the right material for the cells, right? And most of the time, I would say all the time, in order to create a battery pack, all those batteries is going to be from the same style, the same materials, specifically for automotive application, because the size of the entire pack, the final product, not only the physical size, definitely the capacity and everything is super important, and we are not going to create a huge battery pack because, as I said before, it's gonna impact just even the final product as a vehicle, not only the energy part of it. Even, for example, it will impact the speed, it will impact the quality, the price, and everything. Therefore, now we are done with those steps and those requirements. Today, I'm going to focus more on the electrical parts of it, which is going to be building the connection between the battery cells. Suppose you already picked the right material for your application. Suppose you already created your battery module. Remember, I said the smallest level of battery is a single cell, which means you do have only one layer of positive, one layer of negative, and of course, separator and electrolyte are in between, right? Therefore, this is going to be single cell. When we are creating battery pack, we are planning to connect, if it is like, for example, for electric vehicle application, we are not connecting cells individually. We first create modules. Go watch the previous sessions if you haven't. And after that, we are going to have many of these modules in order to create a battery pack. Therefore, in here, when I'm talking about the connection, either if you are looking at the module, building the module, you have to consider them as cells. if you are looking at creating a path, you have to consider each of this as a module. And a module means number of cells, right? So now, suppose we are going to create a pack, means this each one of this are going to be multiple batteries creating a module. Therefore, if I create them in a way that they have only one end to be connected, means I'm having a series connection. When I'm having series connection, what is going to happen in here? Because in series, they do have series and parallel, which is the one in here. These two, parallel means this is a combination of series and parallel, means this row, they are in series connection. But if look at the columns, right? Not only a single column. A single column, they do not have direct connection. But if you combine all of the column right in here, which is like 3 of them, then you can see the connection in here between these two ends, positive and negative. Therefore, this green means parallel connection. And all of the red one or pink one, whatever the color you wanted to say, these are like the series connection. Therefore, in here, I'm having a series and parallel. Now, if I have only series, it's supposed to be something like this. Only one, like the batteries from this end and the batteries from this end, all of them are connected, right? From both ends, they are connected. Now, remember I said it last time, I'm going to repeat. What would be the difference between this series and parallel connection in terms of voltage and current? Both of them, they do have some impact on the output, but what's the impact? Voltage and current or capacity is going to be impacted, right? So if I have series, means I'm going to add up all the voltage, right? For example, in here, V total is going to be, if this is 1, 2, 3, 4, it's going to be 1, 2, and 3, and 4. How about current? So if I'm having such a scenario, simply means I'm going to increase the voltage, my total voltage compared my initial voltage for each of these modules. It's not even close, right? Therefore, my total voltage for this kind of connection is a like combination of all of this voltage. How about current? Current in here is equal. Current, if I say IT, means total current, or I can even, you can even say capacity. Current and capacity for each module or each cell, they are talking about the same things, means how much power they are going to generate it. For example, if this one is 60 ampere, the whole capacity or the whole current for the system is going to be 60 ampere, right? So IT is going to be, I'm going to write it down. IT is going to be, I total is going to be equal to I1, I2, I3. These are all equal. I4. Make sense? So in connecting with, while I'm connecting series, I'm increasing voltage, but I still keep the same capacity or I keep the same current, but the scenario is gonna be completely reversed while I'm having parallel connection. For parallel connection, I'm increasing, if I'm having only 2, like 3 in here, I'm increasing the current or the capacity. Therefore, I'm going to have I1 plus I2 plus I3 right in here. I think I didn't share my screen. Let me share my screen to make sure you see what I'm doing right in here. So now you're going to have the screen inside the recording. I was talking about this one. So if I'm having like series connection, current in all of them are equal, voltage is gonna be increased. If I'm having parallel connection, which is this one, current is going to be increased and voltage will remain the same in this connection. So I'm gonna have V1 equal to V2 equal to V3. Make sense so far, kids? Everybody got the point? Therefore, for your capstone project for any other project, I keep targeting capstone because I know everybody is having a capstone this semester and next semester. In case this is gonna help you, that's why I try my best to give you some application in there. If you are going to have like motorcycle to run on battery, and probably you are gonna be a bit of creative and create your own battery pack, which is a great project to have it in mind for your capstone, especially since you are automotive students. Automotive industry is going to be more focused on battery than like any other, suppose like for example combustion engine. This is a good practice to have at least a part of your capstone to focus on battery design. Also, you may have other focus, that's perfect, but even a little bit of it is going to be a good point to include in your capstone project and showcase your skill in there, and of course add it to your CV later or your resume later for finding a job, or if you are moving to grad school, definitely that's going to help you in order to secure another position as master's students or PhD student if you want to have a direct PhD. So hopefully this is going to help you in there. So now, in addition to simple series connection or simple parallel connection, more specifically for electric vehicle application, we combine the connection. Simply means we are going to have like a high voltage battery, because the only source of energy for automotive application in terms of like especially electric vehicle is going to be battery. We are not going to focus on combustion engine. Therefore, we are going to create a lot of power in order to run just everything inside the vehicle. So if we are going to create such a system and we are going to connect all of the batteries only in series connection to increase the voltage, of course, this is going to be a very huge patch, which may not fit inside the vehicle. Or if we are going to create, again, lots of increase the capacity, and even for increasing the capacity, we have to have them in parallel connection. Therefore, we need a lot of modules in order to do so. But there are situations, most of the time, we need to increase both of them. In case we need to increase both of them and avoid having too many modules, and under each modules, too many cells, the best practice is combining them either as series and parallel connection, like what I'm having in here. I'm going to clean up the picture. Or as another type of connection, which we call it matrix. Matrix is the best practice for electric vehicle application. What is the difference? If I say only series and parallel, means I'm just connecting this kind of a structure. Just create your series connection, put them aside. At the end, just fit them based on the shape you want for that certain vehicle, because in different vehicle, your module should have their own weight, their own shape in order to fit into that certain vehicle. Therefore, after that, you are gonna, as an engineer, go ahead, connect them also. So whatever you do in this row is going to increase voltage. These are all increasing. VT1 means in first row, VT2 in second row, VT3 in third row. So you are increasing voltage in each row, and then you are increasing current with connecting each of these rows in parallel. Therefore, you are gonna increase both current, means high voltage, and both current and both voltage, means you are gonna have maybe a high voltage battery pack. But sometimes even better to have a mixture of all of this connection. In here, you can see this first row, everything in here, they do have both series and parallel connection, which makes it even more efficient in terms of pack design. So for example, if you consider 1, 2, 3 in here, 1, 2, 3, VT1 is increased in here. Again, if this is 4, 5, 6, I'm gonna just consider VT2 means voltage, means total voltage in row 2. Also, it is increased in here. And then I have 7, 8, 9, total voltage in row 3 also increased. So far, I'm having increasing voltage. And then look at here. Each of this, for example, 1, 4, 7, they do have, instead of in here compared to here, Here, everything has just only one parallel connection. Here, I'm having module 1, 4, and 7 being in parallel. Therefore, one time I'm having increase in current right in here. So I total, I'm going to call this one column 1. And then I have even in column 2, I total in column 2. And then I have the same in column 3. Therefore, at the same time, I'm increasing the capacity even more and more. So this could be a great choice for creating high voltage battery pack. Everybody clear so far about different type of connection that we may be able to use in order to design our customized pack for any application? Here we are focused more on automotive, but it could be done for any application which you need to create a battery pack to power the system. In addition to that one, let's look at here. Remember earlier I touched the term BMS, right? BMS stands for Battery Management System. Nowadays, there are lots of ready to purchase battery management system, and a great one which you don't even need to touch them or customize them, because they do have a lot of option to answer any of your need right out of the market. So you just go ahead, you purchase them, you bring them, connect them to your battery pack. How many battery management system you need for a battery pack? Definitely one. Battery management system, in fact, is going to monitor the performance of the battery during operation, either charge or discharge. So you can look at the life cycle, you can look at the thermal management, or I would say the temperature behavior of the battery. You can look at the safety of the battery. You can control operation of the entire battery pack. When I say battery pack, means you simply have option to connect the voltage sensors through this BMS. This BMS has voltage sensor, and of course you can have temperature sensors as well. Temperature sensor and voltage sensor. These two type of sensor which are really accurate, you can connect them module to module if you have module. Or if you have, like, for example, prismatic battery cells, which are very common for electric vehicle application, you can connect voltage sensor and temperature sensor to the tab of each single prismatic cell or cylindrical cell, or if you have pouch type, because we have 3 type pouch. I'm going to show you right in here. This is the pouch type. This is the prismatic type and cylindrical. Because these 3 type of batteries, they could have the same material, but the shape could be different, or they can have different material or different sizes. But there are some difference between them. For example, in here, let's start with cylindrical. Cylindrical is ideal for electric vehicle module creation. But the thing is, they are really good with thermal management. It's easy to have a great thermal management around them. And they are good for large scale system. As I said, electric vehicle means it's a huge battery pack. Definitely, this is large. So these are good options for that. But the thing is, sometimes it's not easy to create any shape of the battery pack with them, right? But otherwise, they are durable. They are good with thermal management system, and they can provide high capacity as well. So these are good options. Many manufacturers, they are using cylindrical battery in order to create their battery pack for electric vehicle or hybrid electric vehicle application. Another type is going to be prismatic. I said it before, I'm going to repeat. In prismatic battery cells, most of the time, the battery is in a rectangular shape. I mean, the cell is in a rectangular shape, something like this. This is what we call it, a prismatic battery. And then they do have tab. Tab means exactly where your positive and negative is connected. The tab of the battery, positive and negative location, can have direct impact on thermal management, or let's say the battery operation during the charge and discharge. Definitely, this is another great research topic for researchers in the field of battery design. Where is the good location or great optimized location in order to install the tap for the battery. Some of them, both positive and negative, are on the same side. Some of them, for example, positive is on this side and then negative on the other side. Some of them in this side and this side. So usually they study the location, the like impact of the location of the tap on the performance of the battery in terms of having a uniform temperature across different spots in the battery. This is super important because sometimes having both of them on top, it causes like accumulation of the heat right in this region, and it may cause some unsafe situation for the operation of the battery, or specifically while the driver is driving and cause maybe some danger. Therefore, they are studying, for example, for that certain pack, is it better to have like regular format, means both the tabs in this location, or move the location of the tab to another direction? So far, so good. Any question? Another type of the battery is going to be, but I would say this one and this one, both of them, they are really durable and strong. But when it comes to pouch type layers are not folded. They are individual layers in here. Therefore, also, there is a great, I would say, advantage with pouch type batteries. They are thick. They are easy to put in any shape of the battery pack because they do not have connection between the layers. They do have individual layer, then they will connect it. They can build the pouch type in any format, which makes it easy to reshape the battery, but still they are not mechanically, I would say, strong enough. The case is most of the time aluminum, but they are not as strong as the prismatic and cylindrical battery are. But they are good for, I would say, they have like, they don't have too much of limitation with the flexibility of how they look like, but they are not, in fact, and they do have like high energy density. Why I say high energy density? Because they can be connected, many of them can be connected and shape customized battery packs. So these are different battery type. Nowadays, manufacturers are using them based on, for example, their vehicle. I'm having a table right in here, which is summarizing like the capacity, weight, energy density, and of course, the type of the cell and the cell density for different vehicles. For example, Nissan Leaf, the capacity is 24 kilowatts. And the battery pack for Nissan Leaf is like 294 kilograms. It's heavy, isn't it? And of course, like the cells used in, or I would say the modules used in Nissan Leaf is going to be pouch. And pouch is like this one, which is the thicker one, since they are going to put together a lot of the battery cells. Therefore, this is a better choice for such a application. Or maybe BMW. BMW is only 230 kilograms, the whole pack, the total number of the cells being added or modules being added to the pack. At the end, the total, the whole product is 230. Cells in BMW are just prismatic cells. And then another one, which is Tesla, fully electric. We need them to be cylindrical in here. Since we are gonna have like fully electric vehicle, we need too many cells. Therefore, this one is a good choice in order to have like a little bit less, I would say, volume. And then we have only the capacity to be 85 kilowatts. And of course, in here, you can see the cell density is higher than every other examples in this table is 251 watts per kilogram. So these are some examples. Any questions so far? Very soon, I'm going to solve one problem for you on how to design a battery pack for electric vehicle application. Therefore, before that, I'm going to show you this example one more time from Nissan Leaf. I said it in the previous slide right in here. I said Nissan Leaf has like 24 capacity and the density of the pack, and do not confuse this one. This one is the density of the pack. This one is the density per cell. These are two different. So now you can see in here, for example, Nissan Leaf, they have like 48 modules in series connection, and they are looking for the capacity to be 24 kilowatts. And you can create something similar by combining, or let's say connecting the modules in either series and connection or a combination of series and connection to build such a battery pack. So I'm going to go to OneNote and start solving this problem for you. Meanwhile, anyone who has any question for me before I start this one, feel free to ask. Everybody has a good understanding of what's the difference between the cell connection or module connection, why we do so, and what's the difference between the shape of the batteries and the material, which we've discussed before. If anything is not still clear, feel free to ask. Then we are going to design a battery pack together. So let's start with summarizing what we have from the example. In here, I have been asked to just go ahead, design a battery pack for an electric vehicle application. Assume you have single cells specifications such as cell voltage to be 4.2 volts. And then this is my cell voltage, and cell capacity to be 5.5 amp hour. And then the battery pack should have the following spec. Your energy per pack is going to be 60 kilowatts. So EP is going to be 60 kilowatts. And the pack voltage, VP, is going to be 400 volts. So these are what I have from the example. Now I have been asked, calculate the number of series and parallel cell. Having this in mind, let's go start the calculation. This is important. Try to learn it and ask me if you have any question. So part one is asking me, what are the number of series and parallel cells? How do we do it? We have one general equations. In order to calculate number of series, I'm gonna name it with NS, and number of parallel, I'm gonna name it with NP. Keep this in mind to avoid repeating it. So number of series, I'm gonna say is going to be the pack voltage. I have it in here. This is pack voltage, which I show it with VP, over cell voltage, and I'm gonna call this one VC, standing for cell voltage. So my pack voltage from the problem is 400 volts, and my cell voltage is 4.2. If you solve for number of series in here, you are gonna have 95.2. Can I include 95.2 cells? Of course not. Should I round it up or round it down? Up. Why is that? Because if I'm looking for 95, like for example, only, probably I'm gonna miss some of the required voltage, which is gonna be generated through another missing cell. Therefore, I'm gonna round up and I'm gonna include 96 cells to be in series connection. This is my number of connection for the series connection. Next, I was asked even calculate number of parallel connection. So for the parallel connection, I'm gonna say pack voltage is equal to NS, which is number of series connection, times VC, means the voltage of each cell. And I have this number of series, I just calculated 96, and then voltage per cell, it was 4.2. Then I can say I'm gonna have 400, 3.2, which is going to be the voltage for the entire pack. Okay, this is the voltage for the pack. Now I have this voltage for the pack. I can calculate the number of parallel cells. So I can say now NP means number of my parallel cell is my total energy, which is, and here I mentioned it from the, this is my total energy from the question, EP, over number of series, cell voltage, and cell capacity. And I already have all of them. These three, I have them from the problem. This one I just solved for it. EP from the problem is 60 kilowatt or 60,000 watts. Number of series, I found it in here, 96. Voltage per cell from the problem is 4.2. And then cell capacity was given is 5.5 amp hour. So if you solve for number of parallel, you're gonna have 27.1. Again, I have to round up because I cannot have 27 cells and 0.1 of the other cell. So then I'm gonna say I'm gonna have approximately 28 cells in parallel. Everyone got the point so far? This is how you calculate your number of series and number of parallel. This is my number of series and this is my number of parallel cell. So let's look at the second part of the question. Now, next I'm asked to calculate the maximum current drawn from the pack for 200 kilowatt motor. So before that, I'm gonna draw some visual from the pack design. So I'm trying to connect my cells in some series. And I just calculated my number of series to be 96. Now I have 96 cells to be connected in series. And then I have the calculation for number of cells in parallel. This is going to be some visual from the final product. I have calculated my number of parallel to be 28, right? So I had voltage per cell to be 4.2 volts. It was given, and I calculated VP. Actually, VP was given 400. It was 400. So now I have to calculate the maximum current in case that I'm having a 200 kilowatt motor. So part 2. Let's calculate for that one now. Therefore, I'm gonna maximum for the pack. How do I do it? I should say current for the pack is the power of the motor given from the problem divided by the pack voltage. Power, it was 200 kilowatts, which is 200,000 watts. And then I have 400 volts for the pack voltage, and it gives me 500 ampere to be the current for the pack. Now, if I have the current for the pack, I can use this one and I can calculate the current per cell. Are you following? Yeah. So how do I calculate current per cell? Any idea? If I have the pack voltage to be 500, how do I calculate the cell voltage? Remember what's equal. This is super important. I'll go back to here. What will remain the same? Look at here, I explained it. What's the difference between series and parallel connection? In parallel connection, current is going to be added up. Therefore, I can simply use this method in order to calculate. So I'm gonna in here come up with the calculation. If I'm gonna calculate current per cell, I can say what is the pack current? That one divided by number of parallel, right? So if pack current is 500 divided by 28, which I found it right in here, I can say each cell is going to have 17.85 ampere. Make sense so far? Yeah. Therefore, this is current per cell. So far, so good. Next, I have to calculate the C rate. How do I calculate the C rate? I said it before, I repeat. C rate means the current which we are going to apply to the battery either during the charge or discharge. So if I have the I cell, this one, for the I cell per C rate, so I have I cell, I just calculated current per each cell, which is going to be 17.85. And then I have the capacity of each cell. It was given, right? So now I can say 17.85 divided by that 5.5. This one is ampere. Therefore, if I'm going to do it with 1 C rate, it becomes 3.2 C rate. This is how you calculate your C rate. So what I need is 3.2 ampere, which is going to be the C rate. Next, what was the next part? Next is asking me, assume 100% efficiency charging time. How long it will take with this C rate to charge the battery? That's a good one. Let's go for this one now. So now I'm going to calculate part 3. Part 3 is assume 100% efficiency, right? Now, and it is in charging. Therefore, I'm going to say level 1. Remember those charger level 1, 2, 3 that I introduced before, right? So I'm going to calculate it. So level 1 AC charging, AC charger is offering how much? Who can remember? What was it? 120. This is level 1 from the previous lecture at 60 ampere. So it depends. If I'm looking for how long it will take for the charge, it depends which kind of charger I'm using, right? So it's super important. If I wanted it to be a fast charge, it means taking less time. Therefore, I have to use higher level, not level 1. If I'm using level 1, I have to say charge time is going to be the pack energy divided by the outlet power. The outlet power, or standing for outlet. I'm writing it. So means I already have this one to be 60 kilowatt. And then the outlet is going to be 100. I'm taking it from here. 100 times 16. I'm calculating power, right? Power means PI. Power means VI, right? So that's why in here, I say VI from the level 1. Then it becomes 31.25 hours. If I'm using level 1, it takes plus 31 hours in order to charge it for 100%. Now, another option is using level 2. Level 2 AC charger. What's the range for level 2? Who can recall? 220, right? 220, and it can cover up to 80 ampere. So then I'm having a bit faster charge time in here. So then I'm gonna say the same equation that I use, very similar to that one. I'm gonna repeat, but the numbers are gonna be different. Charge time in here is going to be 60,000. But now I have 220 times 80, which is going to be fast charging. It takes almost 3 and maybe 3.5 hours or so, almost 3.4. See what's the difference? Therefore, in order to charge with 3.2C rate, if I'm using level 1 charger, it takes what you can see right in here. For level 1 charger, it takes 31 plus hours. And for level 2 charger, it takes 3 plus hours. It's a huge difference, right? Any questions so far? So let's go back to the lecture. Next is about testing the battery voltage. So far, we learned the battery structure. We learned how to design our customized pack. And it's time to look at any troubleshooting. Now you have the pack ready. Suppose even you have been given maybe a chance in order to look at the functionality of a battery pack being installed in an electric vehicle or hybrid electric vehicle. And in case it has some problem or some issue, troubleshoot it. We've got few different methods of testing. So it's simple. You can grab your multimeter and connect it to the leads, or as I just a few minutes ago said, to the tab of the battery, positive and negative, and read like the voltage through the multimeter. But there are situations we may look at the surface charge. Surface charge is a situation where your battery reads more than the actual given voltage or nominal voltage of the battery. And why is that happening? In fact, I would say for lead acid batteries, this is normal if you have surface charge. Why is that? Because remember I said lead acid battery is a bit slow. Since it is slow in operation during charge or discharge, therefore there are going to be some surface charge, because like the ions are coming to the surface and it takes a little bit for the battery to upgrade its status. That's why we do have surface charge, because the ions are closer to the surface and it will be read as, for example, so if it is, for example, 12 point maybe 2 or 3 or what, or just 12 for the actual battery volt, 12.28. If I'm having 12.60, that's normal if it is lead acid, because I do have some surface charge. How do I get rid of surface charge? Most of the time, especially if you are going to externally charge the battery, this surface charge means some stored ion, which is not still used inside the system, and simply you can connect the battery to a load, either an external load to get rid of the surface charge, or simply if it is the actual vehicle, turn on the headlamp. For a few minutes, turn on the headlamp, and if you turn on the headlamp, it will get rid of the surface charge, and the battery voltage rate is going to be normalized again. And that's how we get rid of the surface charge. And we have to do it because if you have it like in there stored, it might create a little bit of dangerous situation. So after we charge the battery, in order to normalize the battery service, you can simply turn on any load, more specifically, or I would say the easiest, the headlamp, right? So another thing I need to show you in here, look at here, any number that you see under the SOC, these are going to be the actual information for the battery. And then whatever you see under in here, it might be like the information from the test or multimeter. So for example, if your battery is full charge and it is showing, the multimeter is showing 12.6, simply means you are going to have surface charge. You have to get rid of it. At 75, still it is 12.4, very close to normal, but at 50%, it becomes a bit more close to normal, comparing to the actual nominal voltage of the battery. So this is relationship between the battery voltage and the state of charge. For example, 75 calculated, it becomes 12.4, 50, 12.2, and so on. I'm going to just pause for a few minutes, give you a little bit of break, and then I'll pick up from where we pause. You can go for break. Then I'm going to add a little bit more about other different method of charging. And if we have time, I start the charging system. So let's go back to the testing, different type of battery testing. So far, I said one of the easiest method for testing is going to be using your multimeter. Look at the voltage of the battery. And next one is going to be load testing. Load always, as I say, it could be just anything that you are going to connect as an load, for example, a motor, something, either external or internal. When the battery is inside the vehicle, we are going to use this method, which we are going to connect this load, which is going to be one of the common devices in order to look at the functionality of the battery being installed inside the vehicle. So load tester has another name. We call it load tester. Has another name, which is carbon pile. I'm going to shortly show you how we can install a carbon pile or attach the load tester to the vehicle and look at the functionality. So in here, you may need to stop by any shop, because this is not something that everybody by themselves they can do it, or even they have the equipment. Meanwhile, I'm playing this one. At some point, I'll probably pause it and I'll explain if needed. If you need me, ask me.
Carbon pile load tester.
So look at here.
Test this battery.
This one is the load tester.
What we're going to do is bring the tester over here and connect the negative and the positive.
This one has layers of carbons being compressed and as a load, connecting it to the battery. So therefore, these two leads in here are super important. I'm going to let it go. You can see some holes are connected.
Make sure to observe the polarity as you connect these, and try to get a good connection.
And they can
it may mean that you have to wiggle this around and get a good bite on that battery terminal.
This is super important.
The same thing here.
To adjust the pressure.
And we're going to want to check the voltage. You want to make sure that the battery is at least 75% charged, or at 12.4 volts or higher before you perform this test. Otherwise, you're testing a battery that's drained and the results don't mean much. Now, we need to come over here to the battery and find the cold cranking amp rating of the battery.
Between the two layers inside that machine. You
can see that right here, the cold cranking amps of this battery are 490 amps.
And they adjust the clamping pressure.
So what we'll do is we're going to apply a load of half of the cold cranking amps, which is 245 amps, and we're going to use the black scale right here. Don't worry about the other scales. So I'll turn this knob right here. This knob begins to apply a load to the battery.
They can adjust it.
And once I get there, once I get to 245, I'll come over here and look at the voltage of the battery. And it should stay above 9.6 volts, and it should hold that for 15 seconds.
If you look at the test,
you'll hear the tester start to beep. That means you can turn it off. If I can see after just a few seconds that this battery is going to pass, I don't need to sit there and run the load for the full.
So I'm going to pause it right in here and go back to the main lecture. Next one is going to be the conducting testing. Well, in fact, conducting is looking at how much power the battery can produce, right? So again, it's not something complicated. Again, you can use your voltmeter in order to do the conductive testing. But in here, you are not measuring the voltage. You are looking at the amount of the power the battery can produce. So you are going to apply some small AC, in fact, AC current to the battery. Then through this device, you are going to measure the voltage. That's what we call it conducting testing. So you have to apply AC current and then look at the voltage. And through that, you are going to measure and understand the performance during the charge and discharge for the battery. Another method that you can see is drain testing. In case drain testing is required in case you have, for example, self-discharge for the battery. If you have self-discharge, as the name can introduce, the battery is going to lose the power or drain the voltage through some source. Either there is maybe a bad connection here and there. Therefore, this is going to be a bit more challenging when you have like self-discharge or drain voltage. So you have to disconnect every fuse in order to test, disconnect and test, in order to figure out what part of the electronic device is being connected to the source is going to be the reason for that leakage or that voltage loss, which we call it drain testing. Therefore, you have to make sure that lots of measurement in this process are involved. But the thing is, you have to avoid starting the battery, especially if you have a drain testing. First, figure out if there is a bad connection, fix it, make it stable, then start like the drain testing. So your car should be off, all of the devices on the dash here and there, all of them should be off. Then you are going to use multimeter and you are going to measure the current. It has to be, if it is in a good condition, it has to be something at around 20 to 50 milliampere, because everything is off, right? Anything less than this range means that you are going to have some concern or something which is going to drain the current. So you need to disconnect each fuse and then measure it. Another testing method is going to be, this one is probably something that many of you or all of you had the experience, or at least you witnessed, maybe your parents did it, which we call it jump start. But before explaining the jump starts, I'm going to explain what will happen in case you are having a frozen battery, which is common here in Canada during the winter time. But I'm going to just take you back to the previous discussion about the battery material. Remember, I told you we are going to have some electrolyte inside the battery. And I, of course, clarified it. Electrolyte has water, right? Inside the electrolyte, you are going to have, electrolyte is a liquid, but most of the time it could be water and salt, right? Therefore, if you are living somewhere like Canada, you might have experience like your frozen battery during the winter time. Simply means that water inside the electrolyte is frozen. If the water is frozen, or I would say the electrolyte is frozen, what was the functionality, or I would say impact of electrolyte inside the battery? Why we need electrolyte? This is a good challenge. Who can answer this question? Yes. Yeah, electrolyte is helping to move the electrons from positive to negative during the charge and negative to positive during discharge. That's what electrolyte is helping, right? Now, If my electrolyte is frozen, what's going to happen to those electrons between positive and negative? And remember, the inside I had, remember, what was water? This is water. So therefore, if the water is frozen, this is supposed to be mixed with some other gas, right? If water is frozen, it's going to generate hydrogen. Therefore, still hydrogen is there. But water is not doing anything. It cannot combine with other electron or other material in positive and electronic. And remember, I had some valve. If you recall from the previous session, if not, go watch those recordings. Inside the battery, especially lead acid, remember I said we do have some valve, built-in valve, in order to get rid of the excess hydrogen and avoid explosion for the battery. Remember that. Now, water is frozen, hydrogen is around. Simply means if I start the vehicle, those hydrogen is in a situation that it can immediately cause explosion. That's why if in wintertime your battery is frozen, you should stop starting or igniting the engine, because any crank may cause those hydrogen to give you like a lot of dangerous situation. Make sense? Now, we have that understanding. Battery is frozen. How do we fix it? That's a different story. We have to just, for example, either change the battery if something urgent situation, or we have to warm up the battery, charge it. I remember I used to live in Quebec years back, and I was seeing this issue very often for everybody. Therefore, everybody, even overnight, everybody's supposed to connect their battery to the outlet to avoid frozen electrolyte or maybe any icy situation for the battery. So they keep, even here in Ontario, I see it, some people, they still do the same. They keep their battery connected to the outlet overnight to avoid such a situation and not to have a dead battery, or let's say frozen battery in the morning. That's one solution for that, which is, as I said, which is dangerous. It may cause, because of that hydrogen, it may cause explosion. Now, suppose the battery is not frozen. For some reason, you've got a dead battery. That's the part that I said you may have this experience. How many of you already had the jump starting experience? Yeah, a good amount of you. So you know how to do it. It's easy. You have to have another rescue vehicle in order to jump start. So get a healthy battery. Simply connect the positive of that like rescue vehicle, the vehicle, for example, somebody else, and connect it to the positive of your own battery. But negative is important. Negative in here is supposed to be grounded. Negative in here could be connected to the chassis, right? And that's how we do jump starting in order to charge the battery. And then we have to, after we have the connection done properly, then we have to first start the rescue vehicle and then start the one which has a dead battery. And keep it until it is charged. Of course, you can use multimeter to see how the state of charge of the dead battery is changing. And right after that, you have to give it a good 20 to 30 minutes drive in order to store some voltage inside your own battery, because the jump starting is not going to give you a stored energy. It's just helping you to crank the combustion engine. Because when the battery doesn't have anything, you cannot turn on the vehicle. Your start is not working. The battery computer is working through, the vehicle computer is working through the battery, not combustion engine, right? So if you do not have a battery, then you cannot power your electronic devices inside the automotive. That's why you have to first connect or jump start the battery to be able to start your ECU. And then after the ECU is started, then you can press your start button if it is a button, or use the key in order to start or ignite the motor. That's how you do it. Therefore, you must give it a good amount of time for driving. Keep the battery like being connected for just some time, then disconnect it, and then drive for some time in order to store some voltage. and avoid similar situation. Any questions so far? Anything for me? Next, we are gonna have another opportunity in here for hybrid and electric vehicle batteries. Well, you need to understand that in vehicle we have different range of voltage inside it. Well, we do have, for example, a 12 volt for auxiliary system. What is auxiliary system or aux system? Who knows that? Any idea? Well, in hybrid electric vehicle, or I would say in HEV, you have a small low voltage battery. That's what we call it, aux battery or aux system, which is 12 volt. And we usually use it for powering up a small component inside the vehicle. Not every component is powered through the same source, which is really beneficial, because in case we are missing or we are having some trouble with other sources, if the aux is still there, we can use aux in order to get access to the ECU. If aux is dead and we cannot turn on the computer of the vehicle, especially for a hybrid electric vehicle, therefore we cannot, hybrid electric vehicle has a still combustion engine, right? We cannot turn on the engine. That's why we do have aux. For example, I'm gonna bring up some of them. For aux, I would say battery. It's a battery, right? But it's a 12 volt battery. You may have ECU being powered through this one. You may have lights. Lights are through this one. Dash is through aux battery, as much as I remember. Any startup electronic, all of them through aux. Door lock, like the turn signals, these are alarm, relay, all of them, many of them, as much as I remember right now. Relay, alarm, door lock, any like a startup electronic, all of them are getting power through your auxiliary system or aux battery. So you do have another one, as just shown right in here, which is going to be your 40 volt system. This one is for assisting a steering. And then you do have another one, which is 288 volt system, which is for the situation that you are not using combustion engine and you are fully on the electric side of it. It's a hybrid electric, right? Therefore, you can see this one is a high voltage. It's 288 for the hybrid drive, right? So now, in cases, I introduced this one to explain this one. In cases that your aux is discharged, now you can only jump start your aux. Very similar method, but you are gonna jump start the aux, because if the aux is not working, you don't have access to the ECU. That's how you do it. Again, in this situation, you need to take like the 12 volt battery. If this is the 12 volt battery, you need to take the lid off. And of course, you need to just connect the cables, as I said, positive to positive or negative to chassis in order to jump start your auxiliary battery. One thing which is important is the material. Well, it used to be 12 volt AGM battery. For example, you can see in here for Toyota Camry, it was and it is AGM battery. But for some other application, nowadays they are using a small lithium 12 volt. Right? Nowadays, since lithium is very common, sometimes they are using lithium ion 12 volts batteries in order to create their aux as well. Some I would say manufacturer, they are using that one. So one more time as a summary, aux battery is a small 12 volt battery that powers electronics, and it will turn the hybrid electric vehicle or electric system, not the motor, okay? Aux battery, it doesn't have anything to do with the motor. Make sense? Next is about high voltage battery safety. Well, battery testing by itself in automotive industry has a whole department. So many different equipment, such as battery cycler, chambers, and many other small devices in order to get the testing done properly and safely. So I'm gonna just summarize some of them. The very first important thing is because battery may release some toxic material. That's super important. And definitely high voltage is also there. So you have two type of danger. But in situation that the battery is disconnected, you are not dealing with the voltage part of it. But still, in case of maybe any leakage, because we troubleshoot when we feel there is a trouble. And what if that trouble is some of the actual chemical are out of the battery, or the battery has that leakage? Therefore, it might be on the surface. You don't want to touch it. It's dangerous. So the most important part is having your like gloves, having your safety glasses, if needed, having the mask. If needed, even the battery needs to be tested inside some, not room temperature, or maybe if the room temperature is hot, move it to the chamber and inside the chamber. So there are lots of factors that needs to be considered. And then you have to make sure the ignition is off and the negative battery cable must be disconnected, both negative and positive. Both of them must be disconnected. And of course, if you are looking at like high voltage battery, you have to make sure your safety plug is removed, right? And definitely like the wires, these are the wires for high voltage application. The cables are thick. Remember I said it's 4, something around 4. So this supposed to be removed. I'm talking about the gauge. These are like thicker wires to be connected to the positive and negative. And of course, since this is a battery pack, remember battery pack is a lot of modules or cells in both series and parallel connection. You have to start removing first the rear, remove the pack from the rear of the vehicle, and then remove the battery insulation or the battery casing. And then gradually you can see after those are removed, you have to look at like the top. These are the top of the battery and see if they are rusted. And in this case, since this colorful materials around them simply means there are some chemical leakage in here. That's why I say you must have your safety gloves, safety glasses, and everything. So first, visually inspect the battery. Anywhere that there is a leakage, therefore, there might be either swelling, either like crack on the surface of the battery, or any other issues, or maybe the insulation of the battery, sometimes it is removed or something like that because of maybe high voltage or leakage or something like that. Next, remember I said, in order to monitor the cell voltage, not the battery pack, not the entire battery pack, monitor the cell voltage and monitor the cell temperature, we do have two type of sensor. We have voltage sensor and we have temperature sensor. These are like the temperature sensor. Most of the time they are T-type temperature sensor, but that doesn't mean always is T-type. It could be a factor of if you are having a battery management system, with that certain battery management system, which kind of sensor are compatible. But for example, here, like in the lab down the hall, last year I created a huge 48 battery wall battery pack, and I was using T-type because my BMS in there, it was compatible only with the T-type. I have some picture of it, probably next session. I'm gonna bring up the actual like the picture which we did last year in there. Therefore, we have to remove the sensor, the temperature and temperature sensors and the voltage sensor, because the temperature and voltage sensor are for the situation that we are connecting them to the battery management system. Now I'm going to troubleshoot, means every single module or cell in there must be checked individually. Therefore, I can use other devices. And then if I have vents in here, or the tubes in here, they are what I'm using for thermal management system. Sometimes I'm having active thermal management system. Sometimes I'm having passive thermal management system. Active thermal management system means like I'm having water or coolant around the battery to move the water around the module or cells in order to cool down the battery during the charge and discharge, which I'm having heat generation. But passive means I'm having, let's say, plates or something else in between. There are different methods, or wax, which we call it phase change material, PCM, phase change material, or PCM. Those are what we call it passive cooling system, which is more common nowadays for high quality battery design. So but if it is active, we have to remove the pipe, or we have to remove the tubes from the battery, because we don't want water around while we are testing. And then we start from the end of the battery, we start removing the case, removing the first layer, removing the cap, and then taking the battery modules. So for example, these are some modules connected. So we have to take them out. And if right now you look at here, I have one of them out, connecting the tabs. This is the positive and this is the negative tab to the multimeter. And I'm looking at the voltage of each module individually to understand. And definitely I have to have a good understanding of what is the expectation from that pack, or what is the expectation based on the manufacturer from that certain cell, and then I can compare it with whatever I can see on multimeter. That's how I can say my battery is in a good stand, or a state of charge, or a state of discharge. It depends what I am measuring or not. So these are the step-by-step procedure that we need to consider while we are testing, or later when you are going to any automotive company. At least you have this understanding what are the steps to take in order to understand the functionality of the battery. Now in this procedure, before I move from this slide, this is a really practical slide. Kids, I may find only one or two modules among all of this to be bad, but still the remaining, and then we cannot fix them if they are bad, right? Because if the chemical of the batteries inside each module is broken or is bad, there is no way to fix it. We have to take it out and we have to replace it with a good one, a brand new one. Still the remaining, but in order to understand which battery is a bad one, or which module I would say is a bad one, I have to check all of them, right? And I had this situation a few years back. It was around the December time. I finished my battery pack. I put it inside the casing, everything done. Very last minute, it was closer to the holiday that everybody's supposed to leave for vacation. And then everything fully functional. I left the battery pack inside the lab, and I'm back around January 10th or something, going back to the downstairs. We have a lab which we are doing this stuff. And then I'm seeing that my pack's supposed to give me 48 volts. Everything fully functional. I was getting 48 before holiday. And when I'm back, I see my pack is providing only 30, right? Means I'm having some leakage. Some of the cells are bad. And I was using prismatic. That's what I said. Next time I'm gonna show you in there what I had. And then I had to take off everything, disconnect, and it's a huge job. It takes a lot of time to disconnect all of your sensors, to disconnect everything, and take every single cell out of the case and see which one is a bad one. And then you know what was the reason? One of my cells, while I got the technician, because the cells were really heavy, while the technician was pushing them inside the case, they didn't care enough, and only a single scratch, even no leakage for the material, a single scratch on the surface of the battery removed the insulation of the surface, and that one had connection with the other batteries, causing this much self-discharge, almost 18 volts or something like that. A single scratch. But in order to understand that, it took maybe a few days to take off all of them, to make sure they are safe for charge, for the testing. And then we found just one scratch can ruin your pack. So that's why I say it is important. Very last slide in here before I finish it and move to the next topic is going to be about the scan tool. A scan tool nowadays, we don't really use the scanning individually in case we have a proper sensors to be connected and look at the functionality of the battery, the temperature, the SOC, the SOD, a state of discharge, the SOH, a state of health, and so on. Even resistance and everything could be nowadays monitored through the battery management system. Therefore, if you have a good quality optional BMS, it could monitor all of internal resistance, battery voltage, the state of charge, health, and even if you have a coolant or you have like thermal management system being included inside your battery pack, it could be monitored through the battery BMS or battery management system. So our battery discussion is gonna be done right in here. Before I close it, anyone has any question for me, feel free to ask. I tried my best to simplify everything about the battery and share all of the fundamental. Again, these are not the advanced version of the battery information, but even if you know just this much is good enough for using it for your capstone or maybe some simple project just in industry. Any question for me? You're not gonna become battery expert knowing this knowledge, right? So you are not expected to be able to design a battery from scratch, battery pack from scratch for automotive application, because as I said, there are a lot of chemical engineering information, mechanical engineering information, electrical and computer. Becoming a battery expert, you have to have four different, I would say you have to consider four different aspects of battery, which is by itself just a whole, I would say, a skill that you need to get. So I'm gonna pause this one right in here, and then I'll start the next one for you. So I'm gonna stop recording.